Let's look at some problems on parabola. Question 1 goes like this. The focus and vertex of a parabola are 4, 5 and 3, 6. Then the equation of the axis is, first option 2x minus y plus 3 equal to 0. Second option 2x minus y equal to 0. Third option 2x plus y minus 13 is equal to 0. And the fourth option x plus y minus 9 is equal to 0. Now there are certain things that we will discuss about a parabola. Now, a parabola, as we know, is the locus of a point such that its distance from a fixed point is equal to its distance from a fixed line. That is, S is a fixed point which will be called as a focus, and you have a fixed line. Parabola, this distance SP is equal to PM. Now a line perpendicular to the directrix, this line is called the directrix. Fixed line is called the directrix. A line perpendicular to the directrix passing through the focus is the axis. Axis of the parabola. It's also the axis of the symmetry. SP equal to PM. Locus of P said that SP is equal to PM is a parabola, and this S is the focus. This fixed line is the directrix. SP equal to PM. Here, eccentricity of the parabola is 1. It's a conic section with eccentricity is equal to 1. Now, here, this point lies on the parabola. SA, let's call it as A. The point where the axis meets the parabola is the vertex. This is the vertex. So obviously, when you are given the vertex and the focus, it is the line joining the 2 points. So what we are given is 4, 5 is the 4, 5 is the focus, and the directrix, vertex is given to be 3, 6. Okay, clearly we observe that if you add these two coordinates, it's coming out to be 9. So x plus y is equal to 9 is the line joining A and S. The line joining A and S, joining A and S is the axis. What is A? Vertex. S the focus, that's the axis, and that is clearly x plus y is equal to 9. What you observe is the sum of the x coordinate and y coordinate of both these points is equal to 9. I can say that this is a linear equation satisfied by the 2 points. So that is the line joining the 2 points, and hence it is the axis of the parabola. So that is the right option is option 4 is the right option. Let's move on to the next question. Question number 2. The vertex and focus of a parabola are minus 2, 2 and minus 6, 6. Then its length of lattice rectum is, first option 8 root 2, second option 4 root 2, third option 16 root 2 and fourth option 12 root 2. You have vertex and focus. For a standard parabola, y square equal to 4ax, a comma 0 is the vertex, focus, origin is the vertex, this length is a, x equal to minus a is the directrix. So the length, distance between the focus and the vertex, if that is a, the length of the lattice rectum is a line parallel to the directrix passing through the focus. So this will be the lattice rectum. This length is 4a. Now we are given, that is for a standard parabola. Now in this parabola what we are given is the focus is 6, 6, minus 6, 6, vertex is minus 2, 2. So what do you observe here? Length of lattice rectum, lengths will remain same. So length of lattice rectum is equal to 4 times distance between focus and vertex. So that is what we observe looking at the standard parabola. So what is it? The length of the lattice rectum is 4a for this parabola, wherein the distance between the focus and the vertex is a unit. So I can say that for any parabola, right, the distance is like this. Length of the lattice rectum is 4 times the distance between the focus and the vertex. What is this? This is the vertex and this is the focus. Now that is 4 times, what is the distance between these two? 4 root 2. Distance AS is clearly 4 root 2. Minus 2 minus of minus 6 whole square, that is 4 square plus 4 square under root. That's going to be 4 root 2, and therefore this is 16 root 2. So clearly the answer is 3. Let's move on to the next question. Question number 3. If the focus and the directrix of the parabola are 3, minus 4 and x plus y plus 7 equal to 0, then its length of lattice rectum is, first option 3 root 2, second option 8 root 2, third option 10 root 2, and fourth option 6 root 2. Okay, let's have a look at this. Again, let's go to the standard parabola and observe what is the relation between the distance between the focus and the directrix and the length of the lattice rectum. So if for the standard parabola y square equal to 4ax, we know that vertex is origin, focus is a, 0, directrix is x equal to minus a. Okay. Now this distance is 2a, because this is a units and this is a units. That's 2a. So 2a. What is the length of the lattice rectum? We said 4a. So the distance from focus to the directrix is half the length of the lattice rectum, or in other words, the length of the lattice rectum is double the distance from focus to the directrix. So length of lattice rectum is equal to 2 times the distance from focus to directrix. Okay. Now what is the focus given? Focus is given to be 3, minus 4. And what about the directrix? Directrix is given to be x plus y plus 7 is equal to 0. So here what you have is the distance between the focus and the directrix is 3 plus minus 4 plus 7 by under root 2. Perpendicular distance formula. ax1 plus by1 plus c by under root over a square plus b square. That has to be a double of this will be the lattice rectum, length of the lattice rectum. So what are you getting here? 7 minus 4, 3, 3 plus 3, 6, 6 by, so 6 root 2. This 2 by root 2 will make it root 2, and we have 6 root 2. So length of the lattice rectum is 6 root 2, and that is clearly appearing in the option 4. Option 4 is the right answer. Let's move to the next question. Question number 4. The focus and directrix of a parabola are 1, 2 and 2x minus 3y plus 1 is equal to 0. Then the equation of the tangent at the vertex is, first option 4x minus 6y plus 5 is equal to 0. Second option, 4x minus 6y plus 9 equals to 0. Third option, 4x minus 6y plus 11 equals to 0. And fourth option, 4x minus 6y plus 7 is equal to 0. Let's again look at figuratively what is the situation. Here we are given that the focus is 1, 2. And the directrix is 2x minus 3y plus 1 equal to 0. This is the vertex. Let us say the foot of the perpendicular from focus to the directrix is z point. This length and this length are same. Both these lengths are same. A, that is vertex, will be the midpoint of this SZ segment. What is Z? The foot of the perpendicular from focus to the directrix. Now the tangent at the vertex, this is the vertex. Tangent at the vertex will be parallel to the directrix, and we can say that it will be in the middle way between the lattice rectum. This is lattice rectum. What is lattice rectum? A line parallel to the directrix passing through the focus. That's a lattice rectum. So this is the lattice rectum. Okay, so this tangent at the vertex, this is the tangent at vertex, that is clearly in between the two. It's in the middle way between, it's parallel to both these lines and then middle way. So let's write the equation of the lattice rectum. Equation of lattice rectum first. Step 1. Equation of lattice rectum. It's a line parallel to the directrix. So it has to be having the same slope as the directrix. What's the slope of this? 2 by 3. So I can say the line parallel to this and passing through 1, 2. So I can write it in the form of 2 into x minus 1 minus of 3 into y minus 2 is equal to 0. Okay. So it is a line passing through 1, 2, which is parallel to this, can be written like this: 2 into x minus 1 minus 3 into y minus 2 equal to 0. What is that? 2x minus 3y minus 2 plus 6 makes it plus 4 is equal to 0. Now the directrix, what was the directrix given? Directrix is given to be 2x minus 3y plus 1 is equal to 0. The line that we required, tangent at vertex, has to be in between them. So what is it? It has to be parallel to these two lines. So I will say they differ. It differs only by a constant, and in fact the constant will be the average of these two, 2x minus 3y plus 1 plus 4 by 2, that is equal to 0. So when you have, let's recall one fact, when you have two parallel lines, a parallel line which is going in between, so let us say this line is ax plus by plus c1 equal to 0, and this line is ax plus by plus c2 equal to 0. A line which is going in the middle and parallel to both of them, middle, and that is this distance and this distance are same. Okay, that line is given by ax plus by plus c1 plus c2 by 2 equal to 0. So we are using that fact here. So to this line which is in the middle of these two lines, the tangent at the vertex can be given by that. So that is 2x minus 3y plus 5 by 2 is equal to 0. So we will multiply by 2 to avoid this fraction here. 4x minus 6y plus 5 is equal to 0. So we have here 4x minus 6y plus 5 equal to 0 to be the tangent at the vertex, and that is clearly appearing in the option 1. So option 1 is the right answer. Let's move to the next question. Question number 5. The parabola x square equal to py passes through the point 12, 16. Then the focal distance of the point is, first option 57 by 4, second option 73 by 4, third option 13, and fourth option 18. Now let's have a look at this. X square equal to 4ay in general is a standard form of a parabola whose axis is y-axis. So it appears this way, whose axis is y-axis, and the vertex is origin. The tangent at the vertex will be the x-axis, this is the y-axis. Now the focus is 0 comma a for this. The directrix will be, this is a units, directrix will be y equals to minus a. Okay. Now we are given that x square is equal to py. That was the parabola given. So the shape of it should look like this, and it is passing through the point 12 comma 16. So 12 comma 16 can be substituted here. 12 square is equal to p into 16. So what are we having here? 144 by 16 is equal to, or p. This implies p has to be 8. So x square is equal to 8y is the given parabola. So matching it with the standard form, comparing with the standard form, a is equal to 2. That is, I am comparing with the standard form. So a is equal to 2. Now, so 0 comma 2 will be the focus. All right, 0 comma 2 will be the focus. So in fact, there is one result here. X square equal to 4ay. If you take any point P on it, say x1 comma y1, the focal distance SP will have to be this distance. That's clearly, you observe that SP has to be equal to the distance from here. This is y1, this length is y1, and this length is a. So it has to be a plus mod y1. So SP here, in this case, a plus mod y1. So modulus of the y coordinate of that point. So now what is the y coordinate of the point that we are given? The point to be 12 comma 16. We are given the point to be 12 comma 16. So what is that? X square, the focal distance, that is distance of the point. So this is the formula. This is a simple observation. The focal distance of the point, this is SP, is equal to, we know it's equal to PM. That's how we generate the parabola. So SP is equal to PM. Now what is this length? PM length, this length plus this length. This is A units and this is mod y1 units. So A plus mod y1 will be the focal distance of the point. So modulus of the y coordinate. What is A for us? 2 plus modulus of the y coordinate. What is the y coordinate with focal distance of 12 comma 16? So this is your y1. So 12, A is this, and so 16, this is mod y1. A plus mod y1, that is 18. Therefore that is clearly appearing in the option 4 is the right answer. Option 4 is the right answer. In this context, let me also mention one thing. When you have a parabola y square equal to 4ax, this type of parabola y square equal to 4x, where the axis of the parabola is the x-axis, the directrix is x equal to minus a, the tangent at the vertex is x equal to 0, focus is a comma 0. If you take any point P on it, x1 comma y1, the focal distance of it has to be given by, that is SP is given by a plus mod x1. This is the focal distance of the point here. That is for the parabola y square equal to 4x, it is a plus mod x1, similar to what we have seen for the parabola x square equal to 4ay. Okay. So coming back to the question, the option was a plus mod y1, and that was 2 plus 16, and therefore that is equal to 18. So the right answer is option 4. Let's move to the next question. Question number 6. The length of the lattice rectum of the parabola 2y square plus 3y plus 4x minus 2 is equal to 0 is, first option 3 by 2, second option 1 by 3, third option 2, and fourth option 6. What is the parabola given? 2y square plus 3y plus 4x minus 2 is equal to 0. It's not in the standard form y square equal to 4ax, but it can be brought into the standard form. Y minus k whole square is equal to 4a into x minus h. That is, now the vertex is, if you shift the origin to h comma k, the equation turns out to the form of capital Y square is equal to 4a into capital X, shifting origin to h comma k. Origin to h comma k. What do you know about origin for this parabola? It is the vertex. So what will be the vertex for this parabola? H comma k is the vertex for this. Is the vertex. So when you write, and what is capital Y equal to 0? It's the axis. Instead of capital Y, what do you have? Y minus k equal to 0. So y minus k equal to 0 is the axis for this parabola. We are talking about this parabola. Y minus k whole square is equal to 4a into x minus h. This is the axis. What is capital X equal to 0 for this? It is the tangent at the vertex. So x minus h equal to 0 is the tangent at the vertex. Tangent at vertex. Okay, right. Now coming back to, let's try to bring this into the standard form here. Coming back to this problem, what is it? I have to bring it into this form, complete a perfect square in y terms here. So what we'll do is, we will take out 2 common from here, and y square, we'll write this as 2 into 3 by 4 because that's a 3 by 2 there. So 2 into 3 by 4y. In order to complete the perfect square, I need to introduce a 9 by 16. So we'll introduce a 9 by 16. So 2 into 9 by 16, that is 9 by 8 is getting added up. Now I will transpose this 4x that side, then minus 4x, and then this becomes 2. What did you add here? 2 into 9 by 16 was added on the left hand side. So we have to compensate for that. And what does that come out to be? Plus 9 by 8. Plus 9 by 8. So now this is in the form of 2 into y plus 3 by 2 the whole square. That I will write it in the form of y minus 3 by 4 whole square. Y minus 3 by 4 minus of minus 3 by 4 whole square. I am trying to bring it into this standard form. So this standard form here. So here 4, we can take it in the form of, it can be either this or minus of 4a into x minus h. If it is y minus k whole square is equal to 4a into x minus 4a into x minus h, it will open to the left side. If it is minus 4a into x minus h, it will open to the left side of h comma k. The parabola opens like this. The vertex will be the same. Y minus k equal to 0 is the axis, x minus h equal to 0 is the tangent at the vertex. All that will remain the same. When you have a minus sign here, it will open to the left. So let's look at this. It appears to be coming into that form. Minus 4 into, what is 2 plus 9 by 8? That comes out to be 16 plus 9, 25 by 8. So 25 by 8. Okay, so x minus 25 by 32, because I am taking a 4 common there. So now clearly observe that, bring this 2 down here. So y minus of minus 3 by 4 the whole square is equal to minus 2 into x minus 25 by 32. So we observe that it is in this form. Y minus k whole square is equal to minus 4a into x minus h. For this parabola, 4a is the length of the lattice rectum. Length of lattice rectum is 4a. Length of lattice rectum is 4a. So what do you have here? Instead of 4a, we have 2. This is okay. This is acting as 4a, and that is 2 here. Therefore, the length of lattice rectum is 2 units. So what is it we have done? We tried to match it up with this standard form y minus k whole square is equal to minus 4a into x minus h, and we brought it in this. Now incidentally, what is the, although it is not asked in the question here, what is the vertex here? Vertex is h comma k. What is the vertex? Vertex for this parabola is 25 by 32 comma minus 3 by 4. Okay, so this is the vertex for it. So this is 25 by 32 comma minus 3 by 4. That's the vertex. And in fact, if you want to locate the focus as well, the distance between the focus, it has to be on the axis. What is the axis? Axis is y plus 3 by 4 is equal to 0. Y equals to minus 3 by 4 will be the axis. On this line, we have to locate the point which is at a distance of a units from here. What is a? 4a is 2, a must have been half. So half units if you move here on this. So 25 by 32 minus half, okay, that is a units. What is a? 4a is 2, so a will have been 2 by 4, that is 1 by 2. 25 by 32 minus half, we have to move parallel to the x axis by a units, and then what do you get here? 25 by 32 minus half comma minus 3 by 4. That would have been the focus. I mean, had focus been asked and had the vertex been asked for this problem, we would have done it this way. So actually in this problem what is asked is only the length of the lattice rectum, but had these two questions also been asked, we would have been able to do it. Anyway, coming back to the problem has the option, right option for this problem. Option 3 is the right option. Let's move to the next question, question number 7. If AB is the focal chord of the parabola y square equal to 4x and A is 4k comma a 4a, then the coordinates of B are, first option a by 2 comma minus a by 4, second option a by 4 comma minus a, third option a by 2 comma minus a by 2, fourth option a by 4 comma minus 4a. Look at this, y square equal to 4x. What is the focal chord? The chord passing through the focus. Now, a general point on this parabola can be written as 80 square comma 280. Okay, suppose now you have a chord joining 2 points T1 and T2. Now I can identify a point with a parametric value t. So if I know t, I know the coordinates of the point on the parabola. So T1 and T2, suppose they are the points on the parabola. Then this chord equation, let us see what this comes out to be. What is the slope of this? This point will be 81 square comma 281, and this point is 82 square comma 282. And this equation of this chord will be y minus 281 is equal to, the slope of this will be 2a into T2 minus T1 by a into T2 square minus T1 square, that into x minus a T1 square. So that is, I am just using the point slope form here, a 2-point form. Okay, so what is this we have here? Y minus 2a T1 is equal to, a cancels and we have T2 plus T1 here. So 2 by T2 plus T1 into x minus a T1 square. Now you can actually write this as, multiply this with T1 plus T2, cross multiply, y into T1 plus T2 is equal to, minus 2a t1 t2 minus 2a t1 square is equal to 2x minus 2a t1 square. This minus 2a t1 square minus 2a t1 square can be cancelled here. So what do we have here? Y into t1 plus t2 is equal to 2x plus 2a t1 t2. Now that is a chord joining 2 points on the parabola whose parameter values are t1 and t2. That is, when I have a parabola y square equal to 4x, at square comma 2at is a general point on it. So suppose t1 and t2 are the 2 point parametric values of 2 points a, p and q on this parabola. The chord joining them is given by y into t1 plus t2 is equal to 2x plus 2a t1 t2. Now what if this chord happens to be a focal chord? That means it has to be passing through the point a comma 0. So suppose this is t1 and this is t2. What is the relation we can arrive at between t1 and t2? Let's have a look at it. So if it is passing through a comma 0, suppose a comma 0 lies on it. If a comma 0 lies on it, that is, if the chord passing through if the chord joining t1 and t2 is actually passing through the focus a comma 0, then you will have 0 is equal to a plus 2a plus 2a t1 t2. So that gives us t1 t2 to be equal to minus 1. So this is the condition for t1 and t2 be the extremities of a t1 and t2 are the parametric values of the extremities of a focal chord. So what is it? The product of the parametric values of the extremities of a focal chord has to be equal to minus 1 here. So when it is in the standard form y square equal to 4x, we have this relationship. Now we are given that one of the points here, one of the points is 4a comma 4a. So 4a comma 4a is one of the points. Let us say this is 81 square comma 281. So what is t1 for us? Clearly t1 has to be 2. Observe this from here, t1 is 2. Now if t1 is 2, what should be t2? t2 must have been minus 1 by 2, because t1 into t2 is given to be minus 1, right? That is this condition we have to bear in mind, t1 into t2. So t2 is minus 1 by 2. So if t2 is minus 1 by 2, the corresponding point, the other end of this, what is the coordinates of it? a2 square, a into t2 square comma 2a t2 are the coordinates of the other point. Let's call this as p and this is q. This is p and q here, q. So what is that? Q coordinates are, instead of t2 I can write minus 1 by 2, that is a by 4 comma minus a by 4 comma minus a, and that is clearly appearing in the option 2. So option 2 is the right answer. So this is a theory here that you need to remember, or finally the condition that you have to remember is, if t1 and t2 are the extremities of a focal chord, or that is the parametric values of the extremities of a focal chord, then the product of these values has to be equal to minus 1. What I have done was this 4a comma 4a, I found the parametric value corresponding to it, that we called it as t1. Then the other end, let's call it as t2. How did we find the parametric value? t1 into t2 is minus 1. So t2 has to be minus 1 by 2. And now write the coordinates of this point, at2 square comma 2at2, that is will be a by 4 comma minus a, and that's clearly appearing in the option 2. Therefore option 2 is the right answer. Let's look at the next question, question number 8. The equation of the parabola whose vertex is 2 comma minus 3, axis is parallel to the x-axis, and the latest rectum is 8 units, is first option y plus 3 the whole square is equal to 8 into x plus 2. Second option y plus 3 whole square is equal to 16 into x minus 2. Third option y plus 3 whole square is equal to 8 into x minus 2. And fourth option is y plus 3 whole square is equal to 32 into x minus 2. If h comma k is the vertex and the axis is parallel to y axis, parallel to x axis, parallel to x axis, it will actually be passing through h comma k, so therefore it has to be y equal to k. And if this is happening, length of latest rectum is suppose 4a, then the equation of the parabola with this information can be written as y minus k the whole square is equal to 4a into x minus h if it is opening to the right of h comma k, or y minus k whole square is equal to minus 4a into x minus h. So that is, the shape of this parabola will have to be like this. The shape of this parabola will have to be like this. This is the vertex h comma k. This is the axis y equal to k. Here is the same, y equal to k, vertex is h comma k. Okay. So when it is minus 4a into x minus h, that is all the while we always assume that a is positive here. So minus 4a into x minus h, if it is like that, then the parabola opens to the left of h comma k, and here if it is plus 4a into x minus h, and 4a is the length of the latest rectum there. Okay. So coming back to the question here, the vertex is given to be 2 comma minus 3. So instead of h comma k we have 2 comma minus 3. And what else we are given? 4a is the length of the latest rectum, that is 8. So let's straight away write it. Y minus k whole square, that is y plus 3 whole square, is equal to length of the latest rectum into x minus the x coordinate of the vertex. What is that? X minus 2. X minus 2. And that's clearly appearing. It could be this or minus of 8 into x minus 2, but none of the options are suggesting that thing. Okay. So we have to go by the options, and clearly option 3 is the right answer. Option 3 is the right answer. Okay, let's move to the next question. Question number 9. Equation of the parabola whose axis is horizontal and passing through the points minus 2 comma 1, 1 comma 2 and minus 1 comma 3 is, first option, 5y square minus 2x plus 10y plus 20 is equal to 0. Second option, 5y square plus 2x minus 21y plus 20 is equal to 0. Third option, 5y square plus 2x minus 21y plus 40 is equal to 0. And fourth option, 3y square minus 9x plus 10y minus 15 is equal to 0. Now, there is one point that we must note here. A parabola whose axis is parallel to horizontal means axis is parallel to the x-axis. Axis of the parabola is parallel to the x-axis. This is the x-axis maybe. This is the axis of the parabola that is parallel to the x-axis. The equation of this is given by, can be taken as x equal to some ay square plus by plus c, where a, b, c are the things that we need to fix by using some conditions, some information about the parabola. So now, since we are given that the axis is parallel to the x-axis, we can write it in this form, x equal to ay square plus by plus c. Now what if the axis were to be parallel to y-axis? Then how do you write this? That is, this is our y-axis, this is y-axis. Axis of the parabola is, this is the axis of the parabola. Axis of the parabola is parallel to the y-axis, then the equation of the parabola can be taken as y equal to x square plus bx plus c. I need to find out this ABC using some information about the parabola, but that is just for information. Now what we are given in our problem is that the axis is parallel to the x-axis, therefore I can take x equal to ay square plus by plus c. That is, when it is parallel to x-axis, I will take x equal to a quadratic expression in y. If it is parallel to the y-axis, I will take y to be a quadratic expression in x. So here, coming back to the problem, now how do I find out this ABC? We need to be given some 3 independent informations to find out these values of ABC, and we are already given that. 3 points are given on it. Minus 2 comma 1 lies on it. So instead of x we can write minus 2, and instead of y we can write 1 here, a plus b plus c. Okay, so that's one equation. Minus 2 comma 1 I have substituted here. 1 comma 2 also lies on it. So instead of x we have 1. So 4a plus 2b plus c is equal to 1. That happens to be the second equation. And also we are given minus 1 comma 3 lies on it. So x equal to minus 1. So 1 minus 1 is equal to, what do we have? 9a plus 3b plus c is equal to minus 1. Now solving for ABC and substituting here, we can easily solve for ABC, that is, eliminate c from these 2 equations, subtract first equation from second equation, eliminate c from here, then you get the values of ABC, substitute back the values of ABC, and straight away we can easily see that option 2 is the right answer. So option 2 is the right answer. It is a simple procedure, just solve these 3 equations for ABC and we will be able to find that it is 5a square plus 2x minus 21y plus 20 equal to 0 will be the parabola. So the right option is 2.